Hello everyone. Today we are going to discuss about limit. So if we have a function fxy where x and y are an independent variable, means both x is independent of y and y is independent of x. So the function fxy is set to tend to the limit L as limit L as x tends to a and y tends to b. So this will be possible if and only if the limit L is independent of the path followed by x and y, where x tends to A and y tends to B. So one more condition is to be satisfied that if there is a positive number epsilon A comma B, then there exists another positive number Dale such that fxy minus L modulus is less than epsilon, and epsilon is that positive number for 0 less than x minus a whole square plus y minus b whole square is less than d square. So here both epsilon and d are positive number, and x and y lies in real number, x and y in R. Okay, so this is the definition of limit if we have a function consisting of two independent variables. What is two independent variable is x comma y. So the limit x tends to a and y tends to b is equals to limit x tends to a, y tends to b of the function fxy is equals to L. Now we understand what is a continuity when a function is said to be continuous. So continuous function means what is continuity? A function f xy is said to be continuous at the point a comma b. If limit x tends to a and y tends to b, f xy exist and is equals to f a comma b. ठीक है, तो when limit x tends to a, y tends to b, fxy is equals to f of a and b, means in place of x if we put a and in place of y put b, then what is the result we getting? Then that function is said to be a continuous. And it is to be noted that the limit x tends to a First we apply limit y tends to b fxy is equals to or may not be equal to limit y tends to b limit x tends to a fx comma y. This is not always true. It is not always true. Sometimes it is true, sometimes not. Not always true. So once again, we see that the function is said to be continuous if the limit x tends to a and y tends to b exist of the function fxy exist and is equals to f of a comma b, and limit x tends to a and limit y tends to b or fxy is not necessarily always equals to limit y tends to b, limit x tends to a fx comma y. So based on this, we will have some problems. We will solve some problems. Like first example one is limit. We have to evaluate this limit x tends to 1 and y tends to 2. 3x square y x square plus y square plus 5. Okay, so what we will do that first we will apply limit y tends to 2 and then limit x tends to 1. So we can write it as limit x tends to 1 and limit y tends to 2, 3x square y x square plus y square plus 5. So first we apply limit y tends to 2. So in place of y, we will write 2. So inside we will get 3 into 2 is 6. 6x square. And below we will get x square plus 4 plus 5. That is x square plus 9. Now we can apply x tends to 1. That means in place of x we can write 1. 1 square is 1 and 1 plus 9 is 10. So this will be 6 by 10 and this is equals to 3 by 5. So what we will do, if we have given two limits, first we will apply this lower limit, means y tends to 2, and then we will apply x tends to 1. Always we will follow this method because sometimes it is possible that if we will change the order, we will then have different limit. So we will see one more example. Yes. One more example is limit x tends to infinity and y tends to 2 xy plus 4 divided by x square plus 2y square is equals to limit x tends to infinity. First we will take limit y tends to 2 for this function xy plus 4 divided by x square plus 2y square. So what we will do, in place of y we will put 2. So limit x tends to infinity in place of y. So we will get 2x plus 4 and below we get x square 2 to the 4 and 4 to the 8. So we get this. Now when we are having this x tends to infinity limit and we know that 1 upon infinity is 0. Okay, so we will try to make this x to 1 upon x. Okay, so what we will do, that we will take x common here, limit x tends to infinity, and we will take x common here also. Inside we can take 2x common here, and inside we will having x plus 2 by x, and here we will take x common, and inside we will have x plus, sorry, here we will have 1 plus 2x, 2 by x, and here we will have x plus 8 by x. So we can say that, we can see that these x are cancelled and we are having this. So we write again limit x tends to infinity 2 into 1 plus 2 by x and x plus 8 by x. So we can see here, we are getting, if we put x tends to infinity, means here infinity, 2 by infinity is 0. We are getting 2 above, okay? And here we are having infinity plus 8 by infinity. 8 by infinity will be 0. Means 1 upon infinity is always 0. 1 upon infinity is 0. Okay. So here we get 2 by x. Okay. 2 by x. And x tends to infinity is equals to 0. Here in the denominator, 1 upon 2 upon infinity will be equals to 0. So this is, and now I hope that you will able to solve all the kinds of limit problems for various function. And if you are having any queries, you can write in the comment section. This is for the limit, and in the further lecture we will study some more problems like partial derivatives. Thank you.